Morning everyone, this is Sir Topper. So we are now on the next lesson all about geometric mean and geometric series. So let's start with what is geometric mean? In general, the terms between any two non-successive terms in a geometric sequence are called the geometric mean. It could be numbers a sub 1, a sub 2, a sub 3 form a geometric sequence. The numbers a sub 2, a sub 3, or a sub n minus 1 are called geometric means between a sub 1 and a sub n. Let's have the concept of geometric mean. It is a number inserted between two given numbers so that the terms form a geometric sequence. In geometry, it is called the mean proportional between two numbers a and b so that a, m, b form a geometric sequence. So in symbol, a over m is equal to m over b. Thus, cross multiplication, we have m squared is equal to a times b. And solving for m, we just have to square the equation. So we have m equals the square root of a times b. Therefore, the geometric mean between two non-successive terms is the square root of the product of the two terms. So let us have this. Example number 1. Insert two geometric means between 3 and 192. So first, let's have the given. A sub 1 is obviously equal to 3. A sub 4 is 192. You are going to insert 2, therefore all of them is 4. So n is equal to 4. So let's have the solution. Using the formula for the geometric sequence rather. So we have a sub 4 is equal to a sub 1 times r raised to n minus 1. And by simple manipulation, by substitution, we have a sub 4 is equal to 3, which is your a sub 1, r is the constant, and n is 4 minus 1. We can also substitute a sub 4 as 192. So we have simplify 4 minus 1 is simply equal to 3r cubed. To get r cubed, divide both sides by 3. So we landed with 4 cubed. So when you say 192 over 3, you must express that in exponential form. Take note that you're going to solve for r. So therefore, your quotient must be shown or expressed in exponential to have same exponent. So they have the same exponent now. Copy their bases. So r is equal to 4. Okay? What are the two geometric sequence? The two geometric means are 3, 12, 48, 192. It's very simple. How? So we can simply multiply 4 by 3. So we have 12. 12 times 4 is 48. 48 times 4 is 192. That's the easiest way in solving this kind of problem. So let's have another example. Example B. The question is, determine the geometric sequence in which a sub 3 is 1/8 and a sub 6 is 1/64. Recall, to find r, we need to assume the third term as a sub 3 to be a sub 1, and the sixth term, a sub 6, becomes a sub 4. It's the same pattern that we had in our arithmetic sequence. So using the formula for geometric sequence, a sub n equals a sub 1 times r raised to n minus 1, and by substitution, we have 1 over 64 equals 1 over 8 times r cubed. And to simplify further, r cubed is equal to 1 over 64 times 8 over 1. So it is equal to 1 8. Very easy. Cancel out 1. Then 8 by 64, and that is 1 over 8, reducing a simple fraction. Okay, and again, you need to express 8 into exponential form. So 8 is simply equal to 2 cubed, wherein you're going to follow that exponent. Okay, take note that 2 cubed is in the denominator. You need to take this 2 cubed to be your new numerator. So in this case, it is equal to 1/2. Okay, so just take the reciprocal of this. So it is 2 raised to negative 3. Okay, so when you have that form, r is equal to 1/2. Okay, the geometric sequence is 1/2, 1/4, 1/8, 1/16, 1/32, and 1/64. So let's proceed with the geometric series. The sum of the geometric sequence can be found in much the same way as the sum of an arithmetic sequence. A corresponding formula can be worked out. The formula for the sum of the first n terms of a geometric sequence series is a sub n equals a sub 1 minus a sub 1 times r raised to n all over 1 minus r, where a sub n is the sum, n is the number of terms, a sub 1 is the first term, and r is the constant ratio, wherein r is not equal to 1. Sum of specified number of terms of a geometric series. The sum of any number of terms in a geometric series can be found given the first term, the common ratio, and the specified nth term. Let's have example A. Find the sum of 7 terms of the geometric series. 3 plus 6 plus 12 plus 24 plus and so on. Okay, let's have the given. Obviously, a sub 1 is 3. Then n is 7 because you are asked sum of 7 terms. So n is 7. Then r equals 2 from 6 divided by 3 or 12 by 6, or it can be 24 by 12. So r equals 2. Okay, using the formula for the geometric series, we have s sub n equals 8 sub 1 minus a sub 1 times r raised to n all over 1 minus r. And by substitution, we have s sub n is 3, a sub 1 yan, minus 3, again a sub 1, then 2, and that is your r, and your n is 7. Then 1, copy, minus r is simply equal to 2. Okay. So we have 1 minus 2. Simplify further, s sub n is 3 minus 3 times 128. So that could be from 2 raised to 7 times 3, and that is 128. Then 1 minus 2 is negative 1. Again, continue, simple manipulation. So we have s sub n equals 3 minus 384 from the product from the two terms. This is the product of 3 and 128. Just copy the sign and copy negative 1. Simplify further. S sub n is equal to negative 381 over negative 1, or simply 381. Thus, the sum of the 7 terms of the geometric series 3 plus 6 plus 12 plus 24 plus so on is equal to 381. That's very easy. How about example B? Find the sum of the geometric series 40 plus negative 20 plus 10 plus negative 5 plus 5 halves plus negative 5 fourths. In this case, we have this given. A sub 1, obviously 40. A sub 6 is negative 5 fourths. That is 1, 2, 3, 4, 5, 6. Then n is 6. What is r equal to? It's negative 1/2. Very easy. Just subtract this. So negative 20 by 40 is simply negative 1 half. And you can also do that by 10 and negative 20. It's negative 1 half. So using the same formula, as 7 equals a sub 1 minus r times a 7 all over 1 minus r. We can have, by substitution, s sub n is 40 minus the quantity negative 54 times the quantity negative 1 half all over 1 minus the quantity negative 1 half. Again, we have s of n is 40 minus 5 over 8 all over 3 halves. Simple manipulation again. We have s of n equals 39 and 3/8 all over 3 halves. Simplify farther. S of n is equal to 105 over 4, which is 26 and 1/4. And that is the sum of the given geometric series 40 plus negative 20 plus 10 plus negative 5 plus 5 halves plus negative 5, 4. Okay, so let's have the class enhancement. So we're done with the discussion. Answer each of the following. You need to insert 3 geometric means between 3 and 48. The 6th term of geometric sequence is 96 and the 9th term is 768. Find the 8th term of the geometric sequence. And find also the sum of the first 10 terms of geometric series, 3 plus 6 plus 12 plus 24, and so on. And lastly, you can do this sheet work for practices. Insert 4 geometric means between 3 and negative 96. What term of the geometric series 1/8 plus 1/4 plus 1/2 plus and so on is 16? And what is the 6th term of the geometric sequence when the first term is 8 and the common ratio is 3 halves? What is the 9th term of x, negative x, x, and so on and so forth? And lastly, find the sum of the first 6 terms of geometric series 0.2, 0.02, plus 0.002, plus and so on and so forth. Again, this is our topper, your math teacher, and saying thank you and good morning.